All right, so we have a 1/2 kilogram ball spinning in a circle. And this is a situation where here's the center of the circle. We have, I'll draw the little object at the top and at the bottom of the swing, and we'll kind of see how this works. Where here's the string, here's one snapshot, here's another snapshot. And what we're saying is that it's one object going around in a circle, and these are two different snapshots of it. So we want to know the tension in the cord at the top of the swing. So here we've got, again, the free body diagram at the top. We'll need that. So I have the tension pointing down, and I have the weight pointing down. So I have the tension and the weight acting together, and they produce a circular or centripetal acceleration in the object. So we have the tension plus the weight, which is m times g, and that makes the mass. And I'll just say accelerate in the circle, which is v squared over r. So I have the tension, and I'm just going to keep plugging in my number. So 0.5 is the mass. G will take as 10. We got 0.5 here. And then we have v squared, which is 3 squared, divided by the radius, which is 0.5. And so we get the tension plus 5 equals 9 when we do our math. So at the top of the swing, the tension ends up being 4 newtons. And let's remember again at the top of the swing, we say downwards is positive. That's something in our review sheet or in our study guide, and I'm also restating it here. At the bottom of our swing, we have that the positive direction is upwards. And let's draw a free body diagram at the bottom. At the bottom, we have the rope pulling up on the object, but the weight still pulls down. So we have tension pulling up, weight going downwards, and the effect is that the mass accelerates in a circle. Again, this equation, I don't give it to you. You have to be able to come up with that by looking at the free body diagram, seeing that the forces are unbalanced because it moves in a circle, and then writing that equation down from your own creative thinking and your knowledge of physics. So we have tension minus mg equals m v squared divided by r, and let's plug it in our numbers. So we have tension minus 0.5 times 10 equals 0.5 times 3 squared divided by 0.5. So we have tension minus 5 equals 9. We add 5 to both sides. We end up getting 14 newtons for the tension at the bottom of the swing. Now we're trying to make it around the circle. We want to know the minimum speed to do that. And so we can actually follow quite a bit of the procedure from part A, which I'm actually doing right here. However, the minimum speed means that this tension is 0. That was the rule that we had because you're just barely able to make it over, so there's no extra tension needed. So we have weight equals MAC. So mg equals MAC plus the 0 here. And notice something. We can actually put in our numbers 0.5 times 10 equals 0.5 times v squared, what we're trying to solve for, divided by 0.5. And so we end up getting 5 equals v squared. So v ends up being about 2.24 meters per second, if I have that right. So that's the minimum speed needed to make it around the circle. Now here's what we're saying. Instead, we have a speed of 4 meters per second at the top of the swing, and we want to know the tension at the top. So in other words, if we're going faster than this speed, faster than v min, so we do have tension. So again, everything applies in the previous part. So I can actually use the same setup, free body diagram and setup, and now I can actually put in more numbers. So I have tension plus mg equals m4 squared divided by 0.5. So tension, that's the v squared, and that's the r. So tension plus 0.5 times 10 equals 0.5 times 4 squared divided by 0.5. Those cancel. So I get tension plus 5 equals 16. And when I solve, I actually get an 11 Newton tension at the top of the swing if my speed is 4 meters per second. All right, so that is it for question 2. And we'll take a look at question 3 in the next video.